Good morning, everyone. Today's topic is symbol table. So today we are going to discuss about the symbol table. So basically, symbol table is a data structure. Which is used by the compiler to store the information, or you can say that to remember the information. Right. So basically, symbol table is a type of data structure which is used by the compiler to store the information. What type of information? It can store identifier or any type of symbol which is available in your source language, right? So there is an important thing. For that, we need to create the symbol table and to manage the symbol table, like to create the symbol table, to update the symbol table, to delete something from the symbol table, or to insert into the symbol table. It is not a part of the compiler, but it helps in the generation of the code, final target code, right? And it is a data structure which is actually constructed by two phases of the compiler, that is lexical analyzer and syntax analyzer, and used by the other remaining phases which are left in the compiler. So basically, the construction of the symbol table is the responsibility of the lexical analyzer and syntax analyzer, and other phases uses the information whatever is stored in the symbol table, right? So we are going to cover following things in the in this particular lecture. So what type of information is stored in the symbol table? Second thing that we will discuss about the usage of the symbol table. Third thing that we'll discuss about the operations. Operations on symbol table. What type of operations we can perform on the symbol table? What are the issues in the symbol table design? Right? And next thing that we will discuss about the data structures used to design simple symbol table, right? And last topic that we'll try to cover is the scoped symbol table. So these are the 6 topics that we are going to cover in this particular lecture, right? So first of all, what type of information we are going to store in the symbol table? But before that, there are certain things that we need to know. So what is the identifier? Identifier is basically a name that you give to a particular variable or to a particular function or to a particular label. So whatever is declared by the user in the source language, the name of that particular thing is called as identifier, right? So information that we use, that we store in the symbol table is, we store name of the identifier, we store type of the identifier, we store location of the identifier, and we store scope of the identifier. And there are certain attributes, other attributes, which can vary compiler to compiler. It totally depends on the developer, compiler developer, what type of information he wants to use. Like limit of the array. There are some compilers in which symbol table stores limit of the array. Fields of the record, or parameters and return variable. These type of information can also be stored into the symbol table. It totally depends on the compiler developer, what type of information he wants to store, and he wants to store into the compiler, right? So next topic is, what is the usage? As we have already discussed that there are two phases in the compiler, lexical analyzer and the syntax analyzer. These two phases are used to create symbol table and semantic analyzer, code generation, that is intermediate code generation की बात हो रही है यहाँ पर, error detection and code optimization. These are the four phases that uses the information of the symbol table, right? तो basically semantic analyzer में क्या चीज यूज होती है? Semantic analyzer generally क्या यूज करता है? Type of the identifier. Semantic analyzer को generally क्या चाहिए होता है? What is the type of the identifier, right? This information is used by the semantic analyzer. Okay. Now next, code generation. Code generation को क्या चाहिए होता है? Type of variable, name of variable, and sometime size of variable. This type of information is required, sometimes required by the code generator. Error detection. Error detection को basically क्या चाहिए होता है? All the variables which are defined in the source language. So basically, undefined variable or symbol, this error is identified by the error detection module using a symbol table, right? Then we have code optimization phase, and what type of information it requires? It requires the information regarding the type expressions that we have already discussed in the type checking lectures. What is the meaning of type expression? So generally code optimizer matches whether two type expressions are equal or not. If they are equal, so whether these two type expressions can be merged or not, right? So these type of things are verified by the code optimizer, and further it is used to optimize the code. This information is again used to optimize the code, right? So now third topic, operations on the symbol table. So there are four types of operations that is performed on the symbol table: lookup, insert, modify, and delete. So these are the four operations that we generally perform on the symbol table. So first we'll discuss about the lookup operation. Lookup operation. What do you mean? What do you mean by lookup? Lookup means searching something into the table. So it is basically a search operation, and it is a most frequent operation. It is a most frequent operation because most of the time आपको searching करनी है. Like once your symbols are stored into the symbol table, then every time you have to search that particular symbol into the symbol table. So most of the time this operation is used by all the phases, right? So anything we can look up into the table. It can be name, it can be type, it can be location, it can be scope, anything that you can look up, right? So insert operation, right? Insert means adding some new name, add some new name into the symbol table. If anything comes new in the symbol table, new in the source program, then you have to add that particular symbol into the symbol table. So basically, this operation is used, right? So basically, this operation is used by the lexical analyzer and syntax analyzer. So it is used by the lexical analyzer and syntax analyzer because these two phases are only responsible to create the symbol table or to insert into the symbol table. Then we'll talk about the modify. Whatever is stored into the symbol table, and if it is modified in the future or in the later phases somehow by the programmer, then it needs to be updated into the symbol table. Let's take example. Suppose when I created the program for the first time, I have declared integer x, and in the later phases or in the after 1 or 2 execution, I have converted this x into the data type float. So this information needs to be updated against the symbol x into the symbol table. So this is done by the modify operation. Now we'll talk about the delete operation. Symbol needs to be deleted when its scope is over. If your language is a block language or the procedural language, then obviously we know that there will be a scope of the variable. Like variable can be global, variable can be local, or there are various type of scopes that we use in the programming languages, right? So if in a particular block or if in a particular procedure, variable was declared, it was local, and once the procedure is over and it is not called again in the program, in the main program, then those variable scopes are over and needs to be deleted from the symbol table, right? So delete operation will be used, but it is a least used operation. So if somebody asks you that what is the most frequent operation and which is a least used operation, then you have the answer. Most frequent is lookup, and least frequent is or least used is delete, right? So in this way, these are the 4 operations which are used in the symbol table, right? Now we'll discuss about the issues. So what are the issues in symbol table design? So when a developer is designing a symbol table, what kind of issues or what kind of problems he or she can face, right? So one problem can be, what should be the format of the symbol table? What should be the format? I mean, it should be in the form of table, or it should be in the form of list, it should be in the form of tree. Like what kind of data structure should be used to design the symbol table? Now next issue that the developer faces is the access method, right? Suppose if any phase except lexical analyzer and syntax analyzer wants to access any information from the symbol table, then what kind of searching method will be used by the phases? It can be linear search, it can be binary search, it can be hashing, or any other searching method. So which searching method will be suitable for a particular language with the particular restriction in the symbol table, right? So access method, the developer needs to decide what type of lookup algorithm he should apply. Then the location of the storage, where to store the symbol table. Should it be stored into the RAM, or it needs to be stored into the hard disk? Where to store the symbol table? Like sometimes the size of the symbol table is very large. So कहाँ पर store करना चाहिए? Should it be wholly stored into the secondary memory, or it should be stored into the RAM, or it should be stored into the cache, or some part of the symbol table should be in the RAM, or some part of the symbol table should be in the hard disk, and we can use swap in and swap out according to the usage of the symbol table symbols, right? So it is totally depend on the developer what type of location he wants to give while developing the compiler to the symbol table, right? And the next issue is scope. How to define the scope of the variable inside the symbol table, right? So this is again an issue. We'll see in the later part of the lecture why it is an issue. Because if you have block language or you have a procedural language, then various type of a scope variable will be there. So how to store these variables into the symbol table, and when to delete these variables from the symbol table, right? So this is again an issue for the developer while developing the symbol table. Now we'll discuss about the sixth point, sorry. In fact, it is a fifth point, right? So it was the fourth point. This was the fourth point, issues while designing the symbol table. So we'll discuss about the sixth point. Fifth point, that is operations into the simple symbol table, right? So fifth point is operations on simple, I'm so sorry, data structures. Data structures on simple symbol table. This is our next topic to discuss, right? Okay, so what type of data structures we can use in the simple symbol table? So first of all, what is the meaning of simple symbol table? So simple symbol table ka matlab, the symbol table which is created by the single scope language. What is the meaning of single scope language? A language in which a program does not have any other scope. The variable does not have any other scope. All the variables are declared in a single block, and there is no other block where the same variable can be redeclared. So all the variables are declared in a single block. So it has a single scope, and there is no procedure, no function separately declared, and there is no block inside the language, inside the program. So that is why this type of program is called as a single scope program, right? So we are talking about this type of program. So suppose in the program I have declared X as a variable, and there is a function fun that I have called in the this particular function, and there is a label that I have declared in the function, right? एक और variable चलिए declare कर लेते हैं, A and B. There are two variables in the program, and we need to design the symbol table for this. So there are 4 data structures that we can use to design a single scope table. So first data structure is a linear table. First data structure can be a linear table. What is the meaning of linear table? It is a simple data structure which is array of records actually, right? So it is a simple table which is array of records. Now what informations we use in the we store in the simple linear table? So we store name, table बना लेते हैं इसके लिए. So we store name, we store type, and we store location of the variable. So we have 4 identifiers. So we store name, then we store type of the identifier and location of the identifier, right? So first name is A, type is integer, and location is basically the base address in the memory for A. What is the meaning of base address? आपने CO में already पढ़ा हुआ है, जहां पर ये variable store होना शुरू हुआ है, वो जो starting address है, that is the offset of A. Similarly, B, type integer and offset of B. Now the next is function, type is function and offset of the function. Memory में ये function कहाँ जा करके store होना शुरू हुआ है, the base address of the function. And L1, L1 is a label, and obviously offset of L1. This will be stored into the linear table, right? Now, what are the problems, or what is the time complexity with respect to the operations? So we have operations lookup, then we have insert, then we have modify, and then we have delete. So what should be the time complexity in the linear table? Fine. So lookup means kya hua? Search. So you are searching something. Fine. So worst case complexity will be big O of n. Because if you are searching something and that symbol is at the last of the table, so obviously you have to navigate, sequential search apply karoge, and you have to navigate all the n records. So the lookup time will be big O of n. And similarly, the insert time. What should be the insert time? Insert time will be big O of n. Worst case, big O of n. Why? Because if you wish to insert something into the linear table, so that will be inserted at the last. And right now, if you are at the first location, then you have to insert that particular, then you have to reach to the end of the table. So that is why you have to navigate n records to reach to the end of the table. So that is why the time will be big O of n. But if you are at the last record, then your time will be omega 1. That is the best case, right? So insert में दो टाइम लग रहे हैं, दो केसेस हमने डिस्कस करे हैं. एक हमने डिस्कस करा है वर्स्ट केस और एक हमने डिस्कस करा है बेस्ट केस, राइट? बट इन मॉडिफिकेशन obviously your worst case will be big O of n, and in deletion also your worst case will be big O of n. इनके best case आप सोचिएगा कि क्या होंगे. Insert का जैसे मैंने आपको best case बताया, in the similar way you can find out the best case of lookup, best case of modify, and best case of delete also, right? So now the second type of data structure that we can use to design the symbol table is called as ordered list. This is the second type of data structure. These are the data structure that we can use to design the symbol table, right? So what is ordered list? Ordered list is basically a little modification into the linear table, but it is almost like the linear table, but it has a sorted list actually. Like linear table is the unsorted list, but the ordered list is the sorted list. And one variant of ordered list is called as self-organizing list, which is generally preferred in case of symbol table. Now, what is self-organizing list? First thing, it is a sorted list. And second thing, it is a self-organizing, which means if you will add something into the symbol table, it will automatically inserted in the sorted order, which means the list will automatically sort itself if you will insert something into the table. So that is why with these two features, this particular symbol table data structure is called as self-organizing ordered list, right? So we'll take one example to understand how this list follows the search operation and how this list is actually organized, right? So there is a rule followed in the self-organizing list, and the rule is most searchable identifier will be stored at first pointer, right? Okay, so let's see one example. Suppose this is the list. This is identifier 1. This is identifier 2. This is identifier 3. This is identifier 4. And this is identifier 5. Right? अब इसमें होता क्या है कि जो भी आइडेंटिफायर सबसे ज्यादा एक्सेस हो रहा है, इसको पॉइंट करता है फर्स्ट पॉइंटर, राइट। एंड आफ्टर दिस आइडेंटिफायर अगर प्रोग्राम में आइडेंटिफायर 2 सबसे ज्यादा एक्सेस हो रहा है, आइडेंटिफायर 2 सबसे ज्यादा एक्सेस हो रहा है, तो ये इसके साथ कनेक्ट हो जाएगा, मतलब आइडेंटिफायर 2 विल बी दी सेकेंड वन, राइट। अब आइडेंटिफायर 2 के बाद अगर आइडेंटिफायर 3 एक्सेस हो रहा है सबसे ज्यादा, सो दिस विल बी दी थर्ड वन। एंड इसके बाद सपोज करिए ये वाला एक्सेस हो रहा है, तो दिस विल बी दी फोर्थ वन। एंड इसके बाद ये एक्सेस हो रहा है, तो दिस विल बी दी फिफ्थ वन, राइट। सो इन दिस वे पॉइंटर इज क्रिएटेड। सो बेसिकली एक लिंक लिस्ट बना लेते हैं। सबसे पहले आइडेंटिफायर 4 है, आइडेंटिफायर 4 किसको पॉइंट कर रहा है, आइडेंटिफायर 3 को। आइडेंटिफायर 3 किसको पॉइंट कर रहा है, आई एम सो सॉरी, आइडेंटिफायर 4 पॉइंट कर रहा है आइडेंटिफायर 2 को। आइडेंटिफायर 2 के बाद कौन आ रहा है, आइडेंटिफायर 3। और आइडेंटिफायर 3 के बाद कौन आ रहा है, आइडेंटिफायर 5। आइडेंटिफायर 5 के बाद कौन आ रहा है, आइडेंटिफायर 1, राइट। नाउ लेट्स टेक एग्जांपल कि there is one more entry inserted into the table, and in the second execution compiler realizes that this particular identifier is the most frequent used identifier and the remaining are same. So what will happen, the remaining will be same and this identifier 6 will become the first identifier, right. And obviously the earlier first will become second, third will become fourth, and so on. So this is the self-organizing list, and the pointer will start from the first and it will reconnect the other identifiers. So this is the self-organizing list, and the main benefit of this list is it is a sorted list, so we can use binary search for lookup, right. So this is the benefit of this particular list. Now your assignment is to find out the time, worst time, to find out the worst time for all 4 operations. This is your practice question. You need to find out time. And obviously, if you can find out the best case also, that will be very good. Now, the third data structure that we are going to discuss is the tree data structure. So, third data structure, suggested data structure is the tree data structure. Acha, before starting this structure, I wish to say one thing that these are not the compulsory data structure which you need to follow while designing the symbol table of the compiler. I mean, if you are having another data structure apart from these suggested data structures, you can use that also. It is not the compulsory condition that whatever I'm teaching you, these data structures are compulsory to design the symbol table. You can use any other data structure if you feel so, right? So, but these are the recommended data structures that we use for the symbol table as a developer. So, tree is each entry is represented by node of the tree, right? So we know that the binary tree, so the structure will be same as that tree. So I am trying to design a tree of the program that we have discussed. So suppose first symbol is A, right? So first symbol will be A. First symbol will be A. Then the next symbol is B. So B is greater than A. So obviously this symbol will be inserted into the right side of the tree. The next symbol was fun. and fun is greater than by chance B. So the next symbol will be fun, which will be the right of the B, right? थोड़ा बड़ा कर देते हैं इसको, right of the this symbol, and the last symbol was L. So obviously L1. So L1 is greater than fun. So by chance मेरा जो tree है वो one sided बना है according to the condition of the binary tree. इसको आप line से जब join करेंगे तो हम assume कर लेते हैं कि हमारा जो पहला symbol था वो A था, और या इसको मान लेते हैं कि ये C था, और दूसरा symbol हमारा B था, तो ये यहाँ आ जाएगा, बाकी सारे ऐसे आ जाएंगे, right? So this is your binary tree. Fine. So this type of symbol table will be constructed in the form of tree. Ab, what is the time taken by the lookup operation, insert operation, modify operation, and delete operation? So obviously, if your tree is a proper balanced binary tree, then your time will be log n. I hope ये सबको पता होगा बाइनरी ट्री की हाइट क्या होती है, log n base 2. तो जो सर्च टाइम है वो कितना लगेगा, log n base 2. लेकिन कब, कंडीशन क्या है, if tree is a balanced tree, अगर ट्री बैलेंस ट्री है. लेकिन अगर ट्री वन साइडेड शिफ्टेड ट्री है या वन साइडेड टिल ट्री है, जैसे कि अभी प्रीवियस एग्जांपल में बना था A, B, then fun, then L1. So your tree was right side tilled tree. For that, your time will be like a linear search, big O of n. So to improvise this, what are the suggestions from your side? I don't want कि ये condition कभी भी आए. I don't want this condition कि इसका worst case कभी भी जो है वो linear search के बराबर हो. The case should always be maximum log n. This is I want. So what are your suggestions for this improvement in the tree symbol table? This is your assignment. You have to tell me what type of suggestions you can give me to improvise the symbol table, right? Chaliye. So this is the symbol table that we have already discussed. Data structure जो हमने discuss किया. Now the last and the fourth recommended data structure is hash table. Fourth recommended data structure is hash table. Okay. So what is hash table? This topic you have already studied in the data structure. What is hash table? Can anybody tell me? Hash table is basically a data structure which is organized according to the hash function, right? And the most frequent used data structure for designing the symbol table. It is generally used by the simple symbol table to design the hash table, symbol table in the form of hash table. So basically, all the entries of the symbol table is stored and accessed according to the hash table. Fine. So let's take one example, then you can only understand this. Suppose kariye, you have a value 12, you have a value 23, you have a value say 34, and you have a value 22. These are the values, and my hash function is equals to location equals to key modulus 10. What is the meaning of that? किसी भी आइडेंटिफायर की लोकेशन निकालने के लिए हमने ये हैश फंक्शन डिजाइन करा है कि उस पर्टिकुलर आइडेंटिफायर को हम 10 से डिवाइड करेंगे और जो भी रिमाइंडर आएगा दैट विल बी द लोकेशन ऑफ दैट आइडेंटिफायर इन द हैश टेबल। तो सबसे पहले एक टेबल बना लेते हैं। अच्छा, टेबल में एंट्रीज कितनी होंगी? मॉड आपने 10 लिया है तो विच मीन्स 0 से लेकर के 9 तक की लोकेशंस होंगी, यानी टोटल आपके पास 10 लोकेशंस होंगी। 4, 5, 6, 7, 8 और उसके बाद हम लोकेशंस बना लेंगे, राइट? सो दिस इज द लोकेशन नंबर 0, दिस इज द लोकेशन नंबर 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the locations we have created in the hash table. Now, take the first key, 12. Suppose the identifier conversion SKY number is 12. First identifier was A. And suppose करिए उसका जो conversion है वो आया है 12. So 12 divided by 10. Remainder क्या आएगा? 2. So the 12 will be stored at the position 2. Right? Now, the second value is 23. 23 divided by 10, remainder will be 3. So 23 will be stored at the third location. Now the next is 34. Value will be 4 and 22. Now the problem arises. 22 and 12 will have the same remainder. So they need to be stored in the same key value, but it cannot happen because at the single key, you can store only single value. तो अभी हम एक दूसरा एग्जाम्पल ले लेते हैं, लास्ट में हम इस प्रॉब्लम को डिस्कस करेंगे. So 21 will be stored in at the first location, right? So there is no problem. अभी कोई प्रॉब्लम नहीं आ रही, अभी कोई क्लैश नहीं है. Now come back to the example, previous example. यहाँ पर 22 है और ये जो 22 है इसका रिमाइंडर आ रहा है 2. So it will be stored here. This problem is called as hash collision. Hash collision, because the both values are giving the same location, and in a single location you can store only single value. The solution of this is 2. First, solution is called as open addressing. What is the meaning of open addressing? The compiler, the operating system will search for the next free location. The compiler will search for the next free location. Compiler is actually a part of system software. So compiler will search for the next free location, and the last generated value will be stored into the free location. So 22 will be stored at the fifth location. This is called as open addressing, right? Now, the next solution is hash chaining. Hash chaining. What is this? A list will be generated. Like this is the value, and with this value, list will be generated. One table will be generated. Like कुछ ऐसा सा बन जाएगा situation. Suppose ये लोकेशन नंबर 2 है, तो इस लोकेशन के साथ कई सारी लोकेशन बन जाएंगी. जैसे दिस इज लोकेशन नंबर 2. एट दी लोकेशन नंबर 2 एक पूरी लिंक लिस्ट बनेगी, एंड उस लिंक लिस्ट में 12 स्टोर होगा. 12 के बाद 22 स्टोर होगा. 22 के बाद अगर किसी और का वैल्यू कुछ आया है, रिमाइंडर 2 आया है, तो वो स्टोर हो जाएगा. जैसे 42 यहाँ पर स्टोर हो गया. अब ये तीनों वैल्यूज एज ए चेन किसके साथ कनेक्ट हो गई हैं? 2 के साथ कनेक्ट हो गई हैं. सो इन दिस वे द हैश चेनिंग विल बी डन. You can study this topic on the net or with the topic data structure, right? So these are the two techniques for the solution of hash collision. ये किसका solution है? Solution of hash collision. These are the two techniques, right, which are used to solve the hash collision. So now your practice time. Your question is time taken for all the operations. But there are two scenarios. First, if symbol table is using order addressing and if symbol table is using hash chaining. इन दोनों केसेस में आपका जो टाइम है किसका, लुकअप, इंसर्ट, मॉडिफाई एंड डिलीट का, वो क्या होगा, राइट? So in the next turn, we'll see the scope symbol table. Till now, we have completed the first 5 points. What is the information stored? What type of information is stored into the symbol table? Usage of symbol table, operations on the symbol table, issues in the symbol table designing, and data structure used to design the simple symbol table. So one topic is left, that is a scoped symbol table, that we'll discuss in the next lecture. So I'm stopping the lecture here.